Tonight we are talking about web performance and search engine. I'm Giacomo. I'm a technical SEO. I work at WebSearch in London. I have a pretty technical background and I have previous experience in development. There is something that I love very much that is web performance. We are going to talk about how web performance affects rankings, just a few words. This is something more specific about other technical part of the indexing and crawling pipeline. How search engine crawl and rendering pages, and how it affects your website. So let's start from the beginning. This is the elephant in the room. Everyone is talking about ranking, so we have to say some things. It's been a while that search engine are using speed as a ranking factor or talking about it. It's more than 10 years now, and they have in their official documentation Bing, Yandex, and Google. Google did the biggest step. So they announced the Core Web Vitals, so LCP, FID, and CLS, and these page experience search signals that is going to affect the ranking. So there are a lot of very good content outside. You can check that. We are not focusing much on this tonight. So is speed an important factor for ranking? I mean, I would really love to say, yes, it's the best, it's the biggest one. Yeah, it's not. It's something that is important, but has a tiny or small weight in ranking. So what you can expect? You can expect if you have one or two similar websites in the same SERP, in the same search results, you can expect to jump for one or two positions or something similar. You can't expect really to jump for 20 positions or stuff like that. Why this? This because there are hundreds of ranking signals and speed is not the most important one. I would say the content is the most important one, but I don't want to go through all the SEO stuff in this. So this is a very clear example. An empty page would be very fast, not that useful for users in search engine. So that's why. So we see that Google are going to use Core Web Vitals in the ranking algorithm, but where they get data from. So they say that they are going to get data from Chrome user experience. It's likely a raw version of CrUX, some things that may contain all the URL key metrics that Chrome records. And what is CrUX? So CrUX is like a database that contains all the metrics that real users navigating website, saving for Chrome. So what if my website is not in CrUX? So CrUX has a threshold related to the usage of a specific website or pages. If there is less data than that, you are not in the BigQuery tables or in the API database. You can end up with no data for single pages or no data for the whole origin or website. So let's try to look at these two cases. So what if Google has no data for my pages? So in this case, Google may group URL trying to check the URL structure. So if you have two similar URL or more than two URL, Google may try to use the data for that URL structuring pattern. If not, Google might use data from your subdomains. So this is just an example. If you have something like this, the first URL, if you have more URL like the form one, all of those URL can use the aggregate data if they are without data. But for the second one, it might be the case that Google will use the subdomain aggregate data. And you should remember this if you are planning a new website. So if you're planning a new e-commerce and you have a product link like the second one, you might want to have like a small folder in this, like the /p/product or stuff like that, if you are not already doing in some other ways. If you want to have like a preview in this, you can check the Core Web Vitals report in Search Console, and there are like a list of similar URLs. So you have the issue, you have one URL. If you click on that, you have a list of similar URL, and you can see that they have similar URL structure. So yeah, this is straightforward. And what if if CrUX has no data for my website? So this is not really clear at the moment. There are some possible solutions, not using any positive or negative value for the corporate vital signals. This is something, if you have no data, you are not going to use anything. Using data for over a long period of time. So we are used to see BigQuery table that is using data on monthly base, and API that is using data over the last 28 days. But why not using 2 months of data? Google can do this without any problem because they have the raw data of the CrUX. And the last one can be lab data, so calculating theoretical speed. They are rendering all the page, so they are going to have all a similar way to measure performance over the internet. We might have more information on this when Google will start using corporate vital search, and I update this slide today, obviously, and yeah, on May 2021. So let's debunk a few myths before going forward in a more technical stuff. So is Google using page speed score for ranking? No. And what about AMP? AMP is always seen as a way to have a very quick page, but you can probably have a quicker page, faster page without using AMP. So AMP is not a ranking factor and never has been. Should be really clear. And Google will remove the AMP requirement from Total Story in May 2021. So now you have to choose if you use or not AMP. Probably on other other stuff, you don't have to use these top story eligibility things. So how search engine crawl and render pages. So we are gonna go in a more technical stuff now. We can split what search engine do in 2 main big parts. One is when a user search for some things, and the other one is what happens in the background ahead of time. So when a user search for some things, the search engine get a query and start processing that query, trying to understand the meaning behind that search, trying to extract entities, and all of these natural language processing stuff. Retrieving, scoring the document that the search engine has in the index, and eventually serving to the user a list of results. So how search engine build that index? So to be able to serve user pages, they need to build an index. So they need to crawl out the web, analyze crawled pages, and eventually build an index. This is a scheme that I think Martin Split shared in an event last year, 2 years ago, where we can clearly see what's the pipeline of crawling and indexing. So we can say from this scheme that if a crawler can't access your content, the page won't be indexed and won't be ranked. So if you are stopping the process at the beginning, yeah, the content won't be rendered, indexed, or ranked. So if you have a problem in the crawling part, this can affect everything. And even if your pages are being crawled, this doesn't mean that they will be indexed, or having your page in the index doesn't mean that they will rank. This is more SEO stuff, but something that should be clear for everyone. So let's start looking at the crawler. Crawler is a software that is browsing the web, getting content from domain, from URLs, CSS, JavaScript, stuff like that. A crawler should have and must have some feature. So we are gonna focus more on politeness and performance and efficiency for this talk. Politeness can be explicit, so a webmaster can use robots.txt file to say, okay, this crawler can't crawl this part of my website. or can be implicit. So search engine should avoid requesting too much time a page from a domain, because this can cause some problem to the server. And about this implicit part, we should talk about crawl rate. So crawl rate defines the max number of parallel connection and the mean number between fetches. Together with the crawl demand, that is popularity plus staleness, is part of the crawl budget, but this is not something we are interested in. You can check more in the link. The crawl rate is based on crawl health, and the limit you can manually set in Search Console. I wouldn't suggest anyone to set the limit, because with that limit, you can only lower your crawl rate. So it's not beneficial for your crawl rate. If you have some specific problem, you might use that, but I wouldn't suggest that. The crawl rate depends on the server response time. So basically, if a server is fast to answer, the crawl rate goes up. If a server is slowed down or emits a lot of 500 errors or has connection timeouts, the crawling slows down. So the second feature we are looking is performance and efficiency. A crawler should make efficient use of all the resources that we are giving them, so processor, storage, and network bandwidth. We can use this simplified crawler architecture. Behind the crawl queue, there are a lot of stuff. There are scheduler, there are filters, there are deduplication, there are many stuff. But we are just interested in the last part, because this is the part that is connected to the internet. So let's say we are gonna get a bunch of URL through the crawl queue, and the URL server will distribute those URL through on the robots, because we have many robots, and those robots can connect to the internet and to the DNS server. So let's try to have like an example on this. The robot needs to crawl a page on the example.com domain. So first is going to ask to the DNS server the IP of the domain. If there is no cache for that, is going to the DNS server will go to the example.com and gets the DNS lookup is not something like that, but yes. So if we have the cache, we have the IP back, we can open the connection. After opening the connection, we can get the index and getting the response and close the connection. But this is not really efficient. So a crawler should make efficient use of resources. So can use like HTTP keep alive connection. HTTP keep alive connection allow crawler to request more things on the same connection, and has other benefits on that. So yeah, with a keep alive connection, we can ask more pages, assets, or stuff like that. Here we have only two pages, but we can add this connection can be longer, obviously. In this graph, it's very easy to understand where the crawl rate is. So the crawl rate defines the minimum time between fetches. So if you have a very big crawl rate, the connection can be closed, because keep alive connection after a while, after being idle, can be closed. So if you have a bad crawl rate, the crawling is lower. This is very clear. At the same time, multiple robots can ask multiple URLs from the same domain. And this at the same time is regulated from the crawl rate, because the crawl rate defines also the max number of parallel connection. We used robot to describe the last part of the crawler. We can use fetch, we can use a lot of stuff, but this is just to know that all of the crawler of a website of a search engine are using the same infrastructure to be connected to the internet, and all the crawler sharing the same crawl rate. So a crawler can have the main crawler, the news crawler, image crawler, a lot of crawler, but yeah, it wouldn't make any sense to allow different crawler, different limit on different crawler, because you can load a lot of a server. So this is something I have to say because I'm guilty about this. When I first started writing this presentation, all most popular search engine crawlers weren't using HTTP2 to make requests. And yeah, I was also remembering a tweet from John Mueller, 2016. Yeah, obviously this is not fault, John Mueller fault. We should always understand the context of phrases. So I started thinking, how can crawlers benefit? So instead of thinking, how can crawlers benefit from using HTTP2, I started my research from the wrong conclusion. Crawlers have no benefit in using HTTP2. But then, yeah, then Google published this article, Google will soon speak HTTP2. And I was like, all right, then, yeah, okay. This reminds me that I should never start from conclusion when I'm searching for answer or solution. So let's begin again. How can crawler benefit from using HTTP2? So from the article, we can see that they say that prominent benefits in using HTTP2 are multiplexing and concurrency, header compression, and server push. So multiplexing and concurrency. What they were achieving using multiple robots or thread, each one with a single H1.1 connection, will be possible using one single connection, one single HTTP2 connection with parallel requests. So the crawl rate will be the max number of parallel requests in this case, and not anymore the max number of parallel connection. At the same time, the HPAC connection will be probably more effective for crawlers than browser. This because a crawler is a stateless software. So they are not setting cookies, and they are repeating over and over the same request, different URL, but the same headers. And they might also request more pages than browser. Browser requests one single page, the assets, and close the connection. A crawler can get multiple page, multiple assets. So longer the connection, better the benefit, bigger the benefit. Server push, they already say that this feature is not yet enabled, it's still in the evaluation page. So Google is making massive use of caching, and this seems to be a really good reason to not use server push. And I guess these will probably never enable this. But when we think about web performance, we are too often looking at protocols in a browser-centric way. And we forget that sometimes people might use a specific feature of a protocol in a good way, let's say REST API and server push. So I would really love to see if they can use server push in a different way. So why took Google so long to approach HTTP2? So first, they had to wait for a wide support of the protocol before starting anything. The code complexity, HTTP2 clients were not designed with crawl in mind, so they had to build everything from scratch and add those pieces of code in a already complex code base. And lastly, they had to test regression. So crawling over HTTP2 will cause some problem on our side, on on the people's side. They had to test that. Okay, so now we can look at the web rendering service. Is the last part, is the other part that we are looking tonight. So Google is able to render JavaScript. They're using Chromium rendering engine, and usually one of the latest version, probably the latest one. And we can look at the main point for the web rendering service. So web rendering service doesn't obey to HTTP caching rules. Cache everything, every GET request for an undefined period of time. They are using an internal heuristic and internal algorithms to decide this. So this is something very, very important to remember. They might limit the number of fetches during a rendering. So they must start rendering a page after a number of requests or a period of time, they might stop doing the rendering. and it might not fetch the analytics. This is something that's good for us, that just stopping fetching Google Analytics script or similar main analytics software. It's built to be resilient, so web rendering service will process and render a page even if some fetch fails. So if you have a CSS file that is failed, they will render the page. It's like a browser, you know, when you have an images that is not loaded or a CSS file, just like that. And lastly, it might interrupt script for excessive CPU usage or error loops. So this is the scheme we had before. We can add some new piece on this scheme. So we can add Chrome instances, fetch server, and cache and disk database. So from this scheme is really clear that Chrome instances doesn't have a direct access to the internet, but use the fetch server to get some things from the internet using the crawler. So the crawler will be the same as the other, the main crawler, the news crawler, and stuff like that. The fetch server, before requesting something to the crawler, will check the disk in the database. So if a resource is not in the cache or stale, the crawler will request those on behalf of the web rendering service. So let's make an example. We have this very bad index.html page. In this page, we have style.css and bundle.css. If in the crawling phase, the crawler will get the index HTML, and we also get the assets that are already visible on the page. So visible and in the style sheet, link rel, or in a script source. So in this case, style.css and bundle.css. In the rendering phase, the bundle.css is including another bundle, bundle2.css, and making a fetch to an API that is getting some content. So if we have a second page about .html with the similar assets, we are gonna have something like this, but the same file are gonna use from the cache and not request it again. So how these affect your website? So cache and rendering. Web rendering service is caching everything without respecting HTTP rules, as we've seen. So using fingerprinting for file names and defining cache busting strategy is the way to go. Because if you're using bundle.js, will be cached for, we not really know for how much time, can be hours, can be days, can be weeks, months, and will be used for rendering even if you change the code. This is not usually a problem because Google has some good heuristic to understand when the file changes, but using fingerprinting, you have more control for users and for search engine. Crawl rate and rendering. So as we're seeing, crawl rate is shared between crawlers. And even those requests that crawler makes on behalf of web rendering service don't make an exception. So if the server slows down during rendering, crawl rate will decrease and rendering may fail. Obviously, rendering is quite resilient and it might retry later using cache from past rendering or stuff like that. This is something that we have to look at. So monitor the server response time is something that we should do. Politeness and rendering. So WebRTC can block crawler from requesting some things. If you block a file that is needed for rendering a page, that page can't be fetched and can't be used in the rendering. If instead you have a JavaScript file that is trying to fetch a file and retry every time it failed, web rendering service might just stop that script. CPU usage and rendering. Web rendering limits CPU consumption and can block excessive script run. So in this case, also performance matter. You should analyze runtime performance debug issues and remove bottlenecks. You can use obviously the tools, Chrome Developer Tool and all this kind of stuff. Third-party stuff. Third-party can be bad for many things, but performance, but also for rendering. So let's say you have assets on a 3D part, and the robots.txt or that domain is blocking that assets. So you can't use that for rendering your page. At the same time, the 3D part can have a request timeout, connection error, and stuff like that. If you can't move those assets on your domain or subdomain or stuff like that, you might be tempted to build a proxy caching the response of that. This is just an idea, but this is not something that you have to do. Cookies, session, and local storage are enabled on the Chrome instance, but clear across the page. So if you are loading 2 pages, you can't really use a cookie between those pages. If you are checking the presence of a specific cookie, for example, the language, if you already choose a language, or you are redirecting a user to a welcome page, the web rendering service won't be able to render those page because are going to request every time the page and be rendered to the welcome page because are not going to reuse the cookies every time. Service worker rendering, service worker registration promise are refused every time. You can use web workers. I use this without any problem. But if you're using service worker, just check in your code if the promise are refused or not, or you can hand with this. This is the University of Nevada. This is our search results, and they are printing the error, the service work promise refused on the screen. WebSockets and WebRTC are not supported in the Chrome instance. Render queue rendering. So this is important. Google states that the render queue median time is 5 seconds. In the past, this wasn't really true. Pages were waiting hours or days before being rendered, and this still might be true for other search engines. I believe Google reduced the render queue time for 2 main big reasons. Freshness. If you had to render content, I don't know, big newspaper that using JavaScript for rendering content, you have to be indexed at the same day, or your news are not really useful. The second problem was the error with assets or the dependencies. So when the crawler first requests a page, it tries to get and cache also visible assets on that page. So in the index.html, they try to get the bundle.js, get and cache that. During the rendering phase, the bundle.js dependencies are discovered, requested, and cached. But if you delete the dependencies of bundle before the rendering phase, they can't be fetched, even if the bundle is cached, because you have like, I don't know, a CSS that is connected to the bundle try to get the CSS, but the CSS is not on the server anymore. And before rendering, before executing the script, the browser don't know what they're gonna ask. They're gonna give you the bundle.js. So I guess this was happening a lot in the past, but it shouldn't happen anymore, at least in Google Web Rendering Service. This because now the span between the 2 phases are very short, so they are crawling and rendering. That the time is, as we said, is 5 seconds around. So yeah, this shouldn't be. You have to be very unlucky to be in the middle of that. But I'm not sure about other search engines. So if you can keep your assets a bit on the server, even if you are committing new asset. Yeah, you can just be around 1 day, 2 days, 1 week. It's not that big amount of bytes. And browser events and rendering. So web rendering service Chrome instance don't scroll or click anything. If you want to use lazy loading, you have to use the intersection observer. The Chrome instance start rendering pages with two fixes viewport for mobile and for desktop, and after that increase the viewport size to a very big height, so 10,000 of pixels without any problem, even more. I tested more than 10,000 pixels, more than 100,000 pixels. I tested 1 million pixels. And this is dynamically calculated on a page base. So if your page is very high, the viewport height would be higher than that. So how to debug this problem? Search Console is the best way to do it. At the top of Search Console, you have like a search box. You can type your URL, and if the URL is in Google database, you can get this this box. If you click on View crawled pages, crawl page, you can get this box at the right of the screen, and you have the rendered HTML that is in this left tab, and all the other stuff in the more info that are very useful. JavaScript console message are not printed in this kind of stuff, are printed in other tools. So in the page results tab, you shouldn't worry if images, font, or analytics.js file are not have an error. You don't really care. Those files are not requested in the rendering phase. So just don't worry about that. You can use mobile-friendly test if you haven't access to Search Console, but mobile-friendly tests and other tests that are online are using the same infrastructure of web rendering service, but bypassing cache and using strict timeout than Googlebot and web rendering service. So the final results can be very, very different. And so this is just a word about that. And thank you. Okay.
Wow, I'm exhausted. There was so much information you shared there. That was fantastic. Thank you, Giacomo. Will we be able to share the slides with the audience later on?
Sure.
For all those links?
No
Fantastic.
problem.
I can't believe I didn't realize how complex that process was. All the way from the CrUX data and what happens when you don't have enough data in the database to make a determination of page speed from, through to the web rendering service and all the complexities therein.
Yeah, and I mean, this is just a very simplification of follow tests. I try to add more schemas, more stuff, but just technical stuff that probably are not really useful for people that are not really interested in small bits or stuff like that, like, I don't know, a pixel seconds of JavaScript rendering, stuff like that are not really useful.
Cool. I'll just make a note to the audience that you can raise Q&A through the Zoom webinars feature. But for now, we do have a couple of questions. I'm going to be selfish and ask one from me first. You work at a search company. Do you think that the recent updates and the proposed page experience update are positive for the web and for your business?
Yeah, for sure. I love web performance, and I really love if my day-to-day job will be more near to the web performance, because I work in web performance anyhow. So yeah.
Do you think it's easier to talk about performance in the context of SEO, or do you think it's easier to talk about SEO in the context of performance? How do you approach that conversation?
Yeah, I would talk SEO and web performance in a context of product management and product development. That I think are more interesting. You can think about SEO as a feature, also, and web performance is the same. So your product should be quick, speed, fast enough for people to use it, but also findable, because if you can't find a product, for who you're building.
Yeah, and I like that idea of a fast page or blank page being fast, but doesn't have any value. So it's always a balance.
Yeah, I mean, the search engine main goal is to reduce the information overload. They might use not very, I don't know, fair methods to do that, but you have to have like a list or a way to access information without having all the information together at the same time. So this is something that is, you have to find the best information with all the best feature. But yeah, you can't say that the speed is the most valuable things in, at least in a list of search results. But if you think about using a website, yeah, in that case, speed is going to be probably more important than other feature that you are using for just a list of search results.
Yeah, I guess in the end, Google wants you to have a good experience using their product, and slow pages don't give a good experience.
Yeah. I would love if Google will start using data save header just to.
Yeah. And if more websites observe the data saver header, and deliver differentiated content. Yeah.
Yeah.
Sure. So one last question: what does the crawler do about adverts? So content like ads, does it differentiate between an ad container and the content of the page? And if so, how does it do that?
Yeah, I mean, it depends. If you mean the crawler or the rendering part?
The render.
The render. It depends. If the part of the ads are public, are very common, they probably will block that. If there are some specific part, they probably will render that, and you can have some bad things in your metrics. You can have clicks, but they are not really clicks. But it depends also on how those ads are built. So if they are just GET requests, they will be cached. If they are POST requests, they won't be cached. So you can have multiple requests every time, but they might probably block the Google render, Google crawler through the robots.txt.
Yes, because you don't want to have a load of phantom ad views in your stats. Yeah. I think we have one more question. Oh, this is a good one from Zlatan. If we pick on the theme of single page apps from earlier, what would be the main takeaway in regards to SEO and SPA frameworks?
Yeah, this is not something very easy. So client-side rendered page like a bad piece for SEO people, because in the past Google didn't render those pages in a very good way. So we always think, okay, those are bad. But nowadays that Google and other search engines are rendering and are executing JavaScript without any problem, I don't think you can have much problem with a single page application. But you should serve some content to the crawler to, if you use the page as before, I used the page without titles, without meta description, without content. These are just bad. How a crawler, other search engine can decide, okay, I'm going to render this page. Why? Okay, probably that page has a lot of other ranking signals that are very useful. So you can say, okay, if we render this page, you probably have some things for the user. But yeah, it's something a bit complicated. So you can have that without any problem, but you should at least serve some things to the crawler. I would the best solution, at least for me, is the hybrid rendering. So you are serving the first page as a static page, and after that you're loading your bundle, your React, Preact, or Vue, or what you want. And after that, the clients user can use the client-side rendering. But if Google will get another page, they will get again a static page. I would say some things like that, but it is not a problem anymore like in the past. You can have different problem. So yeah, it is complicated, but yeah, you can do it.
Excellent. Awesome. Well, thank you very much, Giacomo. That was a great talk, and I'm looking forward to reviewing the recording and taking some more notes. So
thank you very much. Thank you for having me.
Pleasure. And I'm not